So if I talk about a line, I went ahead and typed up the definition on your sheet. It's just determined by 2 points. So if it's line AB, you have point A, point B, and it goes through both of those. The big thing about a line is it keeps going both directions. The symbol for line is AB with this across the top. We don't see it a ton in trig, but it seemed like a good opportunity to review it for an ACT or anything like that as well. So lines keep going in both directions. You can switch, it doesn't matter which letter you put first, BA, AB, that's the same. What's different if I say line segment AB? Right. Just from A to B. Notation-wise symbol, there's no arrows on that. So it's just AB with that little segment across the top. What is a ray?
Starts at one point.
Mm-hmm. So if I say ray AB, notation-wise, ray symbol looks like this. So that says it starts at A and it goes through point B. What if I said ray BA like this? It would start at B and go through A. So rays are the only ones where the order matters because one has an endpoint and one keeps going. All right. When you put two rays together with a common endpoint, we get an angle. So an angle is something that looks like that. Okay. Terminology, the sides of an angle are the rays. So this is a side, and this is a side. This point that they share is called the vertex. All right, so these are the things that you might have seen before. What's probably a little bit different is in trig, you're going to hear like initial side and terminal side. When we look at our angles, they're going to have a symbol in them, like this. And so what that means is this ray started with this, or this angle started with the ray down here and ended with the ray up here. So if I draw that, which one would be my initial side? The bottom, because that's my starting. This would be where I end, so that's the terminal side. So initial is just beginning, terminal is ending, and that's based off the symbol in the middle. So if I drew an angle like this, which one is my initial side? And the one the arrow ends at is my terminal side. All right. Any questions so far? We are also going to talk about positive and negative measurements for our angles. So if let's say this is my initial side, and this is my terminal side. There are two ways I could draw an angle, starting at the top and ending at the bottom. One looks like this. What would be the other way I could start here and end down at the bottom? Yeah. Going around like that. This first one that I drew is a negative angle. Okay, it goes meant to go clockwise. So if you're moving clockwise, that's considered a negative positive angle is counterclockwise. So the negative angles is probably something a little bit different. We will talk about how this relates to a circle, and that makes the positive and negative measurement a little more obvious when we get to that part as well. Some other words that we might hear when we're talking about angles. We have acute, right, and obtuse angles. You guys have all heard those things before, right? What's an acute angle? Less than 90 degrees. Because we can now have negative angles, we will specify it's between 0 and 90. So all these definitions, when you learned them, it dealt with positive angle measurements. So acute is just anything between 0 and 90. A right angle is 90, and obtuse,
90 to 180.
One other one that you may not have heard before, what do you think a straight angle is?
180.
Straight line, 180 degrees. All right. Complement and supplement. What's complement? Add up to 90. Supplement? Add up to 180. Okay, these definitions are on your paper, so I just wanted to run through those things. Any questions about those? So let's actually do some math. If an angle is 55 degrees, can you find the complement and supplement? How do we find a complement? We said complements add up to 90, so if you do 90 minus 55, you get 35. I am going to start now telling you to get used to putting the degree symbol on things. Eventually, it won't happen for a while, but we will have another unit to measure angles in other than degrees. And so we need to be in the habit of putting degree symbols when we're talking about degrees so we don't get confused when we have multiple options. How do you find a supplement?
180.
And that gives what?
125.
All right. Let's try a couple from pictures. Do you guys think you could write an equation to solve these? What does this box mean? So these two are complements. So you know 2r plus 3r equals 90. Divide by 5 and we get 18. Make sure we answer the question. What did I want?
Measure each angle.
The measure of each angle. So this angle was 2r, so 2 times 18 is 36 degrees. The other one, 3r, would be 54 degrees. You guys try B. That up to? A line is a straight angle, 180 degrees. And I think everybody had t equals 20. So if you plug that in, your actual angles were 140 degrees and 40 degrees. So far, so good? Okay. Notation. A lot of times you're going to see me write something like this. Trig has some Greek letters in it. This is one we will see a lot. This is a Greek letter called theta. Right? So when I say m, it means measure. This is the angle symbol, and theta. It's saying what's the degree measure of angle theta. So that's just a notation. A lot of times we'll use that if we have multiple angles that we're talking about. So I could say the measure of angle A is this, the measure of angle B is this, and so forth. Apparently, for whatever reason in trig, they ran out of English letters and we switched to Greek. I don't know. But. All right, the new piece is when we are talking about angles. If you are in, up until now, if you were measuring an angle, did it always work out if you had your protractor that it fell exactly on one of the angle lines? No. And so you usually just rounded it and did close enough, right? But in the real world, we can't always round things. If you're talking about navigation, firing a missile, do you want to just round it to the nearest angle? No. If you're talking about surveying property, deciding where the property line is, do we want to just ballpark it? No. These are things that have to be very precise. So you can use decimals, but it's also common to use what's called degrees, minutes, and seconds to be more precise in our measurements. And you could probably guess. What do you think 60 minutes would be equal to? 60 minutes is 1 hour, so in terms of angles, 60 minutes is 1 degree. All right, 60 seconds. What do you think 60 seconds is equal to?
0.1 degree?
Well, let's go in terms of, let's go up to minutes, so we won't go all the way to degrees yet. The notation, 1 tick mark means minutes, 2 tick mark means seconds. So 60 minutes is equal to 1 degree, 60 seconds is equal to 1 minute. So it's just like time if you replace hours with degrees. We can do calculations with those. So if I want to add or subtract angles, we're going to go back to your elementary days. Okay, when you first started adding multiple digit numbers, how did you take this problem and rewrite it? You probably stacked them, didn't you? And line things up, so that's what we're going to do. I'm going to line up my degrees. I'm going to line up my minutes. Now, if I want to add these together, you are actually just going to add your minutes together, add your degrees together. Okay, so if I add my minutes, 35 plus 52, okay, 28 plus 63. Okay. But if you are making plans with your friends, do you say, oh, I'll be there in 2 hours and 87 minutes? No. What would you do with that 87 minutes? You would change it. You would say, well, 60 minutes is equal to 1 hour, so I would be there in 1 hour and 27 minutes, right? So if my minutes turn out to be higher than 60, we are going to rewrite this. I'm going to take away 60 minutes and add it to my degrees. And then take away those 60, so that's 92 degrees, 27 minutes, because I never want to have more than 60 minutes on there. Do you guys understand what I did? So basically, I took away the 60 minutes and I added 1 degree, because they were equal to. So if I want to subtract these things, I'm going to line it up. 180 degrees minus 117 degrees, 29 minutes. All right, that's like 180 degrees and 0 minutes. If I'm trying to subtract my minutes, can I do 0 minus 29? No, so what do you think we do? Borrow. I'm going to take away 1 degree, so this would be 179 degrees. But when I bring that over, 1 degree is how many minutes? 60, so I brought over 60 minutes. So then 60 minus 29, 179 minus 117, this is 62 degrees, 31 minutes. Questions on that? You guys want to try some? Why don't you do C and D? right, so the first one, I didn't do one with minutes and seconds, but we do it the same. You add your seconds together, so we should get 18 seconds. You add your minutes together, so you get 6 minutes. You add your degrees, so you get, okay. Are there any problems with this? 86 degrees, that's too many degrees. If it's over minutes, we have to take away 60 minutes and turn it into a degree. So that would be 73 degrees, 26 minutes, 18 seconds. Did we get that one? Okay. This one, so we have 120 degrees, 0 minutes, and 0 seconds. So you can't do 0 minus 25. I have to come all the way over to my 120. So if I take 1 degree away, that's 60 minutes. But now what do I have to do? I'm going to take away 1 minute. So that's 59 minutes, and this would be 60 seconds. Did you guys figure that out? Good. So 60 minus 25, this is 35 seconds. 59 minus 4, 55 minutes, and 119 minus 101, 18. You'll notice in the book, if it's a single digit, it always puts 04 or 05. I'm not going to count off if you don't put that. If you just put 5 minutes, that's fine. But. All right, so do we feel like we can add or subtract degrees, minutes, and seconds? Okay. The next piece, this will probably be the last thing I get through today. If I have two options, I can do my angles in decimals, or I can do degrees, minutes, and seconds. We should be able to go back and forth between the two, right? So we need to talk about how can I go from one to the other. So I typed up steps there, but let's just kind of look at a problem before we look at those steps that I typed up. If I wanted you to turn this into decimals, so that means I want degrees. I know I have 105 degrees, but I'm trying to find point what. So let's talk here. 20 minutes. How many minutes are in a degree? So that's 20 out of the 60 minutes in a degree. All right, I have 32 seconds. I'm trying to turn this into degrees, so we have to think of a jump here. We know that there are 60 seconds in a minute and 60 minutes in an hour. So how many seconds are in an hour for a degree?
3,600.
60 times 60, 3,600. So that's 32 out of the 3,600. We're just going to add those together. So you can type it all in at once, that way you don't have any rounding error. So I'm just going to type 20 over 60 plus 32 over 3,600. I said thousandth, so 3 decimal places. So I get 105 point. Rounding if needed. So the degree part is just your whole number. You take minutes divided by 60, seconds divided by 3,600. Is that okay? To go the other way, we have to think a little bit differently. So this time I have the decimals. I first need to change this to minutes. So think about, here we divided. What do you think I should do this time? Multiply. So I'm going to take my decimal times 60. And that gives me 15.78 minutes. So I currently have 85 degrees, 15 minutes. But now I need to take this 0.78 minutes and turn that into seconds. Now here's where sometimes people get confused. When we're dividing, we divide by 3,600, right? Because we had seconds, we were taking it in 2 degrees. But this is currently minutes, and I want to go 2 degrees. So what do I multiply by?
60.
Just 60. And that gives me 46.8 seconds. So for the seconds, we just round to the nearest whole second. So we have 85 degrees, 15 minutes, 47 seconds. So why don't you guys try example 6? So how do we do A? So we should get 74.137 degrees. B. We take the decimal times 60. So we know currently 34 degrees, 49 minutes, and then how do we get our seconds? Decimal times 60 again. And that gives us 1.2 seconds, so we round that, that's just 1 second. You can put 1, you can put 0.1, either is fine. Any questions? We've gotten through quite a bit, but I'm going to save this last bit for tomorrow. I will go ahead and give the homework. It's not due yet. We will finish the lesson and have some time to work tomorrow, but we do have 7 minutes or so right now, so you might as well get your homework written down, and if you want to try a few, you can.